Hello, my name is Dr. Coca, and in this video, we're going to be doing the Tetrazole experiment. For this experiment, we have already set up the reaction in this reaction vessel. It's just a glass tube, and in the glass tube, I placed 2 millimoles of one of the nitriles, 4 millimoles of sodium azide, a small amount of a catalyst, so I picked a zinc chloride and placed 55 milligrams of zinc chloride in the reaction vessel. And then 8 milliliters of a 3-to-1 isopropanol to water solution. Lastly, I added a stir bar, and then now this is ready to be run. So we need to cap it. This cap for this microwave vessel has 2 components. So it has this Teflon part to the cap, and then you place the rest of the cap over or screw over the reaction vessel until it's tight. And then now we're ready to run this reaction. So we are going to run this reaction in this microwave vessel, carousel. So you can see perhaps that there are multiple slots for reactions. So I currently have one reaction in one of the slots. I can place this new reaction next to it, and then you can run multiple reactions as long as the reaction is going to be run under the same conditions, basically the same temperature, same time. After I place the reaction vessels on it, I want to place the cap over the carousel and then screw this part on top. And then we can place our carousel inside of the reaction over the microwave reactor. There is a microwave an IR sensor inside of the microwave reactor that measures temperature. So whatever reaction vessel is directly in front of that sensor, it will detect the temperature, and then the system will either increase or decrease the power to increase the temperature or lower the temperature of that reaction. So we can actually control whatever temperature we want to keep this at through this unit, we can actually also set the time that we want to heat it to. And we can also vary the temperature over periods of time. So for example, you could run the reaction for 100 degrees for 10 minutes and then increase it to, let's say, 150 for another 20 minutes. However you wish. You could also change how long the cooling period is or the heating period is, all through this unit. So if we close our microwave reactor, set the temperature, which in this case is going to be 150 degrees, and also set the time, which will be 30 minutes. I usually like to have a 5 to 10 minute ramp up to that temperature that we want to get to. So in this case, 150. So I'm going to set a sort of profile that starts at room temperature, goes up to 150 for about 10 minutes, and then keep it at 150 for an additional 30 minutes, and then eventually it's going to cool it for another 10 minutes. So overall, it'll take roughly about 50 minutes to heat and cool this reaction. And then at that point, we're ready to move on to the purification part of the experiment.